A question from coordination compounds. Give the oxidation state, d-orbital occupation and coordination number of the central metal ion in the following complexes. We are given 4 complexes. First one is K3CO C2O4 thrice. If we separate it into ions, we can see CO C2O4 thrice. This is 3 Ks potassiums. So this will be 3 minus. 3 minus will be the overall charge. Let us find the oxidation state of the central metal ion here, which is cobalt. So let X be the oxidation state of cobalt plus C2O4, that is oxalate, is having a charge of minus 2. Minus 2 into 3 oxalates, 3, giving minus 3 is the overall charge. So X minus 6 equals minus 3. X equals, let us take this minus 6 to the opposite side. It will become plus 6. So we will get plus 3. So plus 3 is the oxidation state of the central metal atom here. Next we are asked the d-orbital occupation. So cobalt atomic number is 27. So we can write its electronic configuration, represent it as argon 3d7 4s2. In its plus 3 oxidation state, we have to remove 3 electrons, 2 from the 4s and 1 from the 3d. So you will have 3d6, 6 electrons in the d orbital. Now you know that oxalate here behaves as a strong field ligand and the electrons will tend to get paired up. That is, it will have an electronic configuration of a d electronic configuration of T2G 6 and EG 0, because those electrons, 6 electrons are getting paired up, and that is how you are getting this d orbital configuration, or d orbital occupation will be T2G6 EG0. And next is, we are asked about the coordination number. So we can see there are 3 oxalate ions. The density of one oxalate ion is 2. So when there are 3 of them, you will have 6 as the coordination number. 6 will be the coordination number. Here, since oxalate is a strong field ligand, it is making the electrons pair up in the lower energy level itself. Next complex is cis CrEn twice Cl2 Cl. So here let us separate it into ions. We will get CrEn twice Cl2. This chloride is having minus 1, so we will put a plus 1 here. Now chromium is the central metal ion here, or atom here. Let X be its oxidation state, plus this is a neutral molecule, 0, plus there are 2 chloride ions, so minus 1 each, minus 1 into 2 equals plus 1, that is the overall charge. So X plus 0 minus 2, X minus 2 equals plus 1. X equals, minus 2 will go to the other side, it will become plus 2, that will be equal to plus 3. So chromium is in its plus 3 oxidation state there. What about its electronic configuration? Let us write for chromium. Chromium is having 24 is the atomic number. So its electronic configuration will be argon 3d5 4s1. In its plus 3 oxidation state, let us remove 3 electrons, 1 from 4s and 2 from the 3d. So you will have 3d3, and these ligands are not very strong. These 3 electrons will tend to stay in the T2G level only. T2G 3, Eg 0 will be the d orbital occupation. Next is coordination number. En is having a density of 2. There are 2 of them. So 2 into 2, that will be 4. And the chlorides 1 each. So 1 into 2. This is the density. So 4 plus 2, 6. 6 will be the coordination number in the case of this complex. Now the third one is NH4 twice COF4. So we know NH4 is having plus 1 oxidation state. There are 2 of them. So this will be plus 2 altogether. So we can write COF4. We are separating it. So this will be minus 2. Since this part is having plus 2, this will be minus 2. So let X be the oxidation state of cobalt here, plus 4 fluoride ions. So minus 1 for 1 fluorine into 4 equal to overall charge of minus 2. So X minus 4 equals minus 2. X equals minus 2. This minus 4 will become plus 4 when it comes this side. That will be plus 2. So the oxidation number of cobalt, which is the central metal atom here, is plus 2. And let us look at its electronic configuration. Cobalt, we saw the configuration can be represented as argon 3d7 4s2. Now its oxidation number is plus 2. So remove 2 electrons. You will be left with 3d7 in the outermost shell. Now we can see fluorine or fluoride. They are not very strong field ligands. They do not pair up electrons. So the T2G and Eg levels will have total of 7 electrons. This will have 5 electrons in here, and this will have 2 electrons in here. So that will be the d orbital occupation, T2G5 and Eg2. Now the coordination number, there are 4 fluoride ions around cobalt. So you will be having a coordination number of 4. In this complex, MnH2O6 times SO4. Separate it into ions. You will get MnH2O6 times 2 minus. SO4 is, 2 plus. SO4 is 2 minus. So this will be 2 plus. Let X be the oxidation state of manganese. X plus 6 water molecules. Water molecule is neutral. So 0 into 6 equals plus 2. So X plus 0 equals plus 2. X is equal to plus 2. Oxidation number of manganese is plus 2 here. Electronic configuration can be represented as argon. Atomic number is 25. So 3d5 4s2. In its plus 2 oxidation state, these 2 electrons should go. You will have 3d5 electrons there. Now, water is a weak field ligand. It is not strong. So it will not pair up the electrons. So you will have T2G 3 Eg2. That will be the d orbital occupation. T2G3 Eg2. Now the coordination number will be equal to, there are 6 water molecules surrounding manganese. Coordination number will be 6. So in this case, you can see there will be unpaired electrons. These 5, there will be 5 unpaired electrons. Okay, the shape of the molecules, we are not asked about it. This is, or the hybridization is sp3d2 in this case, and in this case it will be sp3, and here in the case of this complex, that is cis, that will be d2sp3, and here also it will be d2sp3 hybridization.